Okay, let's continue to talk about the conditional probability. Let's look at example 2. In the card game bridge, the 52 cards are dealt out equally to 4 players, called east, west, north, and south, the 4 directions. If north and south have a total of 8 spades among them, what is the probability that east has 3 of the remaining 5 spades? So here they mentioned if north and south have a total of 8 spades, what is the probability of for the east has 3 out of 5 spades? So which means should given the condition north and south have already got 8 spades out of 13, right? And we understand the 52 cards, right? 52 cards, each should has 13, right? So in the 52 cards, and we talk about the cards problem in chapter 2, right? So in the 52 cards, each shoot has 13, right? Has 13 cards. And we have those 4 shoot, the diamond, cube, heart, spade, right? Those. Now we have like 4 players, okay? 4 players. How can we define it as a conditional probability? So I will describe my event A, which is event F, which is the event occurs, okay? So this is the event occurs. That will be north and south have 8 spades, okay? Have 8 spades. Of course, each player they got 13 cards, right? And then what is the probability we need to work out? East, this means the east has 3 spades, right? Has 3 spades out of the remaining 5, because besides the 8, remove the 8, then we left 5 spades, right, out of 13. So we need to figure out the conditional probability of event E. The east has 3 spades under the condition north and south have already get 8 spades. That is how we represent this probability as a conditional probability. Okay, so that will be the probability. Okay, the probability event E and F both occurs over the probability event F, right? Or you can describe your event E and F as the north and the south have already got the 8 spades, and then east will take another 3 spades, right? And the probability event F, what is this one? This one means the north and south got, so totally north and south they have 26 cards, right? They have 26 cards for those 2 players. So for the event F, they have 26 cards, but they have 8 spades, and the other 18 are other 3 shoot, right? Other 3 shoot. It might be diamond, cube, heart. So that is event F. Let me write it. It's 18. Okay, let me write it more clear. It's 18 here. So for the event F, North and South players, they got 8 spades, but totally they have each player has 13 cards. So two players totally they have 26 cards. Out of those 26, we have 8 spades, and the other 18 will come from the other 3 shoot. Right? Now here, how can we represent? How can we represent the event EF? So that means for the East has 3 spades. East has 3 spades, but how many in the total? Now, for the East, when East is going to choose, we only have 5, right? We only have 5 left. Make sense? We only have 5, the East left. And when we take the North and remove the North and South, the 26 cards, and so for the East and the West player, okay, for the East and West player, out of event F, we still have another 26 cards. But how about those 26 cards? Those 26 cards for East and West, that will be 5 spades plus. So let me write here for the player East, for East and West. What are those 26 cards for those two players? That will be 5 spades left and plus 21 other 3 shoot, right? Other 3 shoot. So totally it's still 26, right? So for the East, he's going to choose 3 spades, but how about the others 10? The East is supposed to hold 13 cards, so he is going to choose another 10 cards, but out of the other 21. And then what is my new sample space now? What is my new sample space? Given the event, North and South have the 8 spades, right? Given the event, the North and South has the 8 spades. So they have those 26 cards, but for the East, we are going to choose the other 13 out of the 26. So that is the conditional probability, because in this way it's not easy to count all the different outcomes in the sample space. It's not as easy as the first one. The total number of outcomes in the sample space is 4. This is not okay. This card problem becomes more complicated, and finally you evaluated these combinations, you get the final answer 0.339. Okay, 0.339. So trying to understand the background, or trying to understand the description of the conditional probability, that is more important. Okay, that is more important. Here we define event F is North and South have 8 spades, but they already got 26 cards. Just 8 spades plus 18 the others 3 shoot. And then given the event F occurs, the conditional probability of event E, which means East has 3 spades. East has 3 spades, so we choose 3 spades out of the 5 remaining spades. But how about the other 10 cards for the East? So for the East, for the player East, he is supposed to have 3 spades and 10 other shoot, right? So 3 spades and the 10 cards for other 3 shoot. And actually, what is the different outcomes for event F? When event F has already decided the 8 spades and plus the 18 cards, we still have 26 left. right? We still have 26 left. Then how can you form all the different cards for the east player? Remove the 26 cards for the north and south. What are all the other possible outcomes for the player east? So it should be the 26 choosing 13, right? Will be 26 choosing 13 for the east players. I saw some of you comment as Damu, but I couldn't catch up. Okay, I couldn't catch up. What is your question? But you can ask me after the class. Okay. So that is example 2 about the cards. Okay, about the cards. What about the probability F? You can calculate it. It's a good question. Okay, it's a good question here. What is the probability F? Right? What is probability F? And you can try that. What is probability F? What is probability E and F? Okay, calculate in this way. But here you need to take about the sample space. You need to, if you are going to evaluate the probability of event F and event E and F, you need to think about the sample space. So how many different outcomes in the sample space if you are going to evaluate it this way? So the different outcomes in the sample space will be, you have 52 cards, 13, right? 13 for the first player, and then the second player will be 39, then take 13. And then the third player, 26 out of 13, and the last one, 13 choose 13, actually is 1. If you consider the question in this way, okay, if you consider the question, you are going to evaluate the probability of event F, the probability of E and F. Your sample space will be all those different outcomes. So that will be more complicated, okay? That will be more complicated. And this is only the sample space, right? So you can think about the question in this way to figure out the question in this way. Now, we will recall one example we did before, okay, about the cards drawn to get the five cards with the 5 consecutive values. Okay, we are not called it straight. Straight means they are not the same shoot, right? Here we are talking about the case. Okay, if the 5 cards for one poker, if the 5 cards are just 5 distinct consecutive values, okay, just the 5 consecutive values. So we are familiar with this situation. Okay, now let's repeat this example. Okay, so one player, he obtained the consecutive sequence of 5 cards. So it can be the same, can be the same shoot. Okay, so what is the probability to obtain consecutive sequence of 5 cards in the same shoot, given that the player has already got 5 cards as a consecutive sequence? So here we can describe my event. We can describe my event F, which is the given condition. Given condition, the player has got 5 cards with consecutive sequence, okay, and including the same shoot, okay, has got 5 cards with consecutive sequence. And event E is 5 cards, 5 sequence in the same shoot, 5 cards with sequence in the same shoot, Now here, we check the sequence. We analyze the sequence previously, right? For example, you can have the sequence from S 2, 3, 4, 5. That is one hand. You can have 2, 3, 4, 5, 6, 3, 4, 5, 6, 7, like that. And finally, the sequence you can have 10, Jack, Queen, King, S, right? You can have those. So for each sequence, so those are all the different outcomes for the for the event F. They got 5 cards with consecutive sequence. They might in the same shoot. Okay, they might in the same shoot. So for example, for the A, so that means you have 5 cards. You have 5 cards here. So if you decided the first card is S, the first card is S, but you can have 4 different shoot to choose, right? You can have your diamond S, you can have your heart S, like that. So you have 4 different choice. And when you decided the first card is S, the other number point I decided should be 2, 3, 4, 5, right? Should be 2, 3, 4, 5. Why I write A 2 times? I didn't write AS 2 times. It's a sequence. I just call the sequence. This gives the sequence of the 5 cards in one player. This is the cards. This is the cards. A sequence gives one hand of the cards. It's not I just write the number. I just list the number. It's not I list the number of the cards S 2, 3, 4, 5, 6. This is just one hand of the card, 5. This is another 5. And you can have some others in the middle, like 4, 5, 6, 7, 8, like that. Okay? So is it clear? Now, if I decided the first one is S, I'm going to have 4 different choice for the shoot. And if the first one is S, actually the other point I decided should be starting from S, then 2, 3, 4, 5. That form a sequence. So for the second two, you can have different shoot. 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 Actually, for one sequence, you have 4 to 5, right? For one sequence, S 2, 3, 4, 5. And how many different sequence we will have? S 2, 3, 4, 5, 2, 3, 4, 5, 6, until 10, Jack, Queen, King, S. So you will notice that the first number you started, that will be S, 2, 3, until 10, you have 10. So totally, F, the F, event F, the player has got 5 cards with consecutive sequence. Event F has 10 times 4 to 5 different outcomes. So everyone is clear? The player has got 5 cards with consecutive sequence, but they might have the same shoot, right? They might have the same shoot. Now, what is event E? Let's check how many outcomes in event E. Event E. Event E, the 5 cards with the sequence should in the same shoot. So for the SA345, how many different outcomes we have? You can have this sequence in diamond, you can have this sequence in cube, you can have this sequence in heart, in spade. So each sequence you have 4, right? You have 4 different outcomes in 4 different shoot, and totally we have 10. We have 10 different sequence you can have, right? So it's 40. Now, what is the probability? What is the probability the player, under the condition the player has already get a sequence for the 5 cards? and then this sequence should be in the same chute. So that will be the, as I said, the number of outcomes in event E, but also in F. Of course, the event E, you get those 40 cards as a sequence in the same chute. That is also contained in event F, right? It makes sense. So that will be the 40 outcomes. These 40 outcomes also included in the event F. Think about it. You get 5 cards. You get 5 cards with consecutive sequence. They might have the same chute. They may not have the same chute, right? And then what is the outcomes in event F? Different outcomes. So that is the answers. Okay, that is the answers. Should be 1/4, 4. Okay, so that is the conditional probability. And here you can understand the event F as two part. Okay, event F as two part. 5 cards, it's a sequence. Okay, 5 cards with sequence, which means the 5 cards are in a sequence, with sequence in the same chute. And 5 cards, this is number 1 and number 2. 5 cards with sequence not in the same chute, right? Not in the same chute, which means at least you have 2 different chutes in the sequence. You might have the heart plus diamond, or you might have all those, right? You can have the spade S, you can have heart 2, you can have diamond 3, you can have cube 4, then you can have spade 5, like that. So event F can be divided into 2 parts: 5 cards with sequence in the same chute, 5 cards with the sequence not in the same chute. So this from here is much more clear to check that event E is the subset of event F. The event E, the 5 cards with the sequence in the same chute, of course, is contained in the event F. So those 40 different outcomes, which gives the numerator, okay, which gives the numerator. And then what is the total outcomes in the event F? So we formed the 5 cards, with different chute. 5 cards, each one has different choice, 4 different choice for the chute. So 4 to 5, and totally we have 10 different sequences. So it's 10 times 4 to 5 different outcomes. That becomes the denominator. That becomes the denominator. So again, it's more important to denote what is the conditional probability. Okay, event F is giving that the event F occurs. The player has already get 5 cards as a sequence. And the question: how did you get event E? 4 times 10. 5 cards with the sequence in the same chute. For example, you can have this sequence S2345. Both, all of them in spade, all of them in diamond, all of them in cube, all of them in heart. So if you decided this sequence S2345, if you have those points in your hand, you can have 4 different outcomes, right? 4 different outcomes, 4 different four shoot, right? You can have 4, and then you have how many sequences you can have? 10, right? 10. As I said, S 2 3 4 5, 2 3 4 5 6 until 10 Jack Queen King S. So that's totally we have 40. Okay, 40 different outcomes. And here again, those 5 cards I list just one hand card in one poker. Okay, just one hand with the 5 cards for one poker. Okay, for one specific poker. So for the card problem, okay, for the cards problem, if we add the conditional probabilities that becomes more complicated to figure. 5 times 10. Why it's 5 times 10? Each sequence we only have 4 shoot. How can you count the 5? Should be 4 times 10 because we only have 4 shoot. There is 4 card? Not 4 card. It's always one hand with 5 card. With 5 card, those 4 means the shoot. Okay, try to check the question in a clear way. Those 4 I write as the shoot, and for one poker they are supposed to hold the 5 cards in hand as a sequence. Okay, so be careful. Okay, be careful. Now for the conditional probability, we can rewrite it in this way. Okay, we can rewrite it in this way. Multiply the probability of f on both sides. So that is the conditional probability formula. And both sides, if we multiply by probability of f, and we know that this one is positive, they cannot reach 0. So we obtain the probability of event E and F equals the probability of event F times the conditional probability. And this one gives us a way. If you know the conditional probability, you can work out the probability of the intersection. Okay, intersection of 2 events. So that is, we rewrite the conditional probability. Now let's look at one example from the Kehan class. Okay, from the Kehan class. Rahul's 2 favorite food are bagels and pizza. Let A present the event that he eats a bagel for breakfast, and event B represents the event that he eats a pizza for lunch. This is much more clear. They already define the event. Okay. On one randomly selected day, the probability that Rahul will eat a bagel for breakfast, PA is 0.6. Okay, this is more straightforward. Okay, the probability Rahul will eat bagel is 0.6, and the probability he will eat pizza for lunch that is 0.5, and the conditional probability that he eats a bagel for breakfast, given is the event occurs, given he eats a pizza for lunch, which is given event B occurs, and then the probability he eats a bagel for breakfast, event A means he eats a bagel for breakfast, that is 0.7. Okay, that is 0.7. And based on this information, what is the probability of this? Be careful, okay? Be careful. Those two are different. This one means this P. Try to read it, okay? Try to read it in the description. Event B occurs. The probability of event A, the conditional probability of event A, that means given Rahul eats pizza for lunch, the probability he eats a bagel for breakfast. And this conditional probability means given Rahul eats a bagel as a breakfast, the conditional probability he eats a pizza. Okay, so we need to work out this one. And actually this the background of this example is doesn't make sense to me. Okay, for me I feel like whether you eat whatever you eat in the breakfast does not affect what you eat for the lunch. Like you eat a bagel in the breakfast as a breakfast, you eat a pizza as a lunch. But we just follow the scenario. Okay, we just follow the examples here. So we need to work out this conditional probability. And this example gives you a way to understand those two conditional probabilities. They are different. Okay, they are different. So follow the formula. Okay, follow the formula. How can we evaluate the conditional probability? follow the formula here, okay? Follow the formula. So to find the conditional probability of event B given event A occurs, that will be the probability event B and A, right? B and A, and over the probability of event A, right? This the denominator is always the probability of the event given, or the probability of the event occurs, okay, under this condition. So we already know event A probability is 0.6. We need to figure out what is probability B and A, right? What is B and A? Then how can we understand this conditional probability? How can we understand this conditional probability? So this conditional probability 0.7 actually is probability A and B over the probability of B, right? Over the probability of event B. Then from here, okay, from here we can check that. Of course, the probability B and A is the same as A and B. They are commutative, right? They are commutative. So this conditional probability, then the probability of event B goes to the denominator. That's why I said those two are different. Okay, this one is given the condition event B occurs, given the condition Rocco eats pizza for lunch, and this one means given the condition this person eats the bagel as a breakfast. So from here, we know that my probability B and A will be conditional probability times PB from this given number, right? From this given number. So what is this one? This is 0.7. What is probability of B? 0.5, right? 0.5. So which is 0.35 and over 0.6, right? Over 0.6, and the answer should be 35 over 60 will be 7 over 12. Just keep it as a fraction, okay? Just keep it as a fraction. So that is example 4, okay? Example 4, you can apply the you can just rewrite the conditional probability to find the intersection, okay? To find the intersection. This is a pretty simple question, and you can watch the video, okay? You can watch the video of these examples. It's about the conditional probability part, okay? Now, multiplication rule that can be extended to the n event, okay? We have already get two event, okay? Two event, intersection of two events, that will be the probability of f. Probability of f times probability, conditional probability E under the given the event f occurs, okay? Under the f occurs. By the way, if you write this one, be careful. As I said, the order of the conditional probability. If you write that equals PF times P F given E, this is wrong, okay? This is even E occurs, it's different, okay? It's different. Be careful about the notation. The probability of F times the probability F occurs. Try to be clear about those notations. Later we will talk about more complicated formula, okay? The section 3 is the Bayesian series, okay? Bayes theory. The multiplication rule, okay? Multiplication rule. If we have the intersection of an event, we can write it in this way, okay? We can write it in this way. That will be the probability of event E1 times the conditional probability of E2 given event E occurs times the probability conditional probability of event 3 E3 under the given the event E1 and E2 occurs. This is read as a new event, okay? New event E1 and E2 occurs. And until the last times the last conditional probability of En given the new event intersection of E1, E2 and En minus 1 all occurs, okay? All occurs. So here it's easy to verify that, okay? It's easy to verify that. You can extend it the right side, okay? You can extend it your right side. The first one is probability of E1. And then this term you can write it. Let me just put here, okay? Let me just shift here. So you can write the first one is probability of E1. And then how can we rewrite the second one, the conditional one? Given event E1 occurs, so that will times probability of E1 as the denominator, and then probability E2 and E1, right? That is how we write the second second term conditional probability. Now what is the third conditional probability? So you take this one as the new event F. So that will be probability of event F as a denominator, right? And then the intersection of E3 and F. My F is E1 and E2, right? And then you can also write for the next one, the next one will be event if conditional probability of event E4 given E1 and E2 and E3, right? So we can rewrite the conditional probability for this one again, so that will be the probability E4, E3, E2, E1, E2, E1 over the probability of the given event E1, E2, E3. And let's write the last one, okay? Let's write the last one. The last one is also the conditional probability, so the top will be actually the intersection of all those events. I just use this notation, EI, okay? EI. And then over the probability, what are all those? From E1, E2 until En minus 1, right? We only have En minus 1 event as a probability of En minus 1 as a denominator. So you will notice that. Let me just use a different color, okay? Let me just use a different color. You will notice that you can cancel out this P1, P1, P2E1, and this one. So you will notice that you will cancel this one with the previous term. And finally, you only left this term. What is this term? That is probability E intersection of those n events. You can expand it as this way. Right? That equals to the right side, left side. That equals the left side. So it's pretty easy to verify that. And this is called the multiplication rule, okay? Multiplication rule. And this one is just intersection of two events. Just rewrite the conditional probability, okay? So we need more practice for the conditional probability. And actually I was planning to move forward for the Bayes formula. The question probability E1 and E2 is the same as probability E2 and E1. Of course they're the same. It's commutative. The event is commutative, right? So students ask this question. probability E1 and E2 will be the same as E2, E1, of course. Right? Because for the event is commutative. E1 and E2 is the same as E2 and E1. Right? So it's almost time. We will stop here today.